Hello everyone, this is for Tuesday, the 24th. This is Literal Equations, not much to it at all. It's just remember the same rules we just practiced yesterday with addition property of equality, multiplication property, addition property, subtraction, all those properties, everything is the same, except now we're just dealing with letters. But the same rules still apply. So they have to tell you what variable they want you to solve for. All right, so in this problem, they want us to solve for y. All right, so the first thing I gotta do is I gotta get rid of this 2x. Remember, I can get rid of a 2x by doing the exact opposite. I can subtract 2x to the other side. So that would give me 3y equals 14 minus 2x. I can't put these two together because they're not like terms. And then once I get y is almost by itself, I'm gonna divide by 3, divide by 3. When I'm done, y is by itself. Now, if you remember when we did these, if 3 can go into one or both of these, then we go ahead and divide it into both of them. But if it doesn't, we just leave it alone. So that'd be 14 minus 2x over 3. That's how easy it is. All right. Now, I did this when I made this up weird and everything. Just if you remember, I did the smiley face and frowny face when we way back. It doesn't matter. You still use the same rules. So if I'm solving for this weird looking W right here, the first thing I got to do is I got to get rid of this triangle and square. Well, the opposite of positive triangle and positive triangle square is negative triangle square. And so you just do the same thing to the opposite side. Sorry for my bad drawing. That's gone now. And so now I'm left with whatever that is, equals theta pi minus star square. Again, it doesn't matter if you can add or subtract them or anything like that. You just put them side by side when you can. If I'm wanting to get this by itself, I do the opposite. It's being multiplied, so I divide. Divide the same thing over here. And I'm done because that's by itself. And there's nothing up there like that. I know it looks weird, but those are the rules. You just follow the rules you learned or you practiced yesterday with addition property, subtraction property, and all that stuff. Remember that if it's more than one number, if more than one term is multiplied to it, you can still divide. If I want to solve for y, it's being multiplied by p and t, then I can divide by p and t. If I do something on one side, I got to do it to the other. Division property of equality. The p and t cancel out over here, so y equals m divided by p times t. Nothing cancels out, so just leave it alone. You're done right there. This problem here, this is more than likely what you'll see. I'm going to solve for g. Here's the g, so that means I got to get rid of this negative fy. If I want to take this negative fy to the other side, I can by adding it. So it'd be h plus fy. These are not like terms, so I can't put them together. That's why I have to just say h plus fy. Now g is being multiplied by c, so I'm going to divide by c. And it's gone. So g is by itself now. Nothing cancels here. C doesn't go into either one of these. If it did, we would go ahead and cancel them out, but it doesn't. So you just leave it as a fraction. Now, if you remember these problems, I showed y'all how to get rid of fractions. If you don't like fractions, then you get rid of them. You multiply by a common denominator. So in this problem, I'm going to multiply this side by 6. And if you do something on one side, you got to multiply this side by 6. What happens here is these 6's cancel, and I'm left with a plus b. 9 times 6 is 54. Now it's just a general normal equation. I'm solving for b, so I want to get rid of the a. I want b by itself, so I need to get rid of a. So I want to take this a over here and make it a negative. b equals 54 minus a. There's no fractions, there's no nothing, and that's it. You're done. So practice these, show your work, and have a good day. Remember, I'm here available from 9 to 12 live on Google Meets, and then also on, you can get a hold of me on Remind as well.